So everybody, this audience is pretty well versed. You're all in manufacturing or in education somehow, and you know how 3D printing impacts everything in manufacturing, from prototyping to parts to products. And new ways are being discovered all the time, from medical research, as you've seen, or engineering, culinary, arts, and fashion. Artists have been quite active in the field ever since it became affordable and people became the consumer actually has become more aware of it in recent years. And artists were among the first to jump on board with figuring out innovative ways to use the technology and pushing the parameters of form and the materials, fusing science, technology, engineering, and art. So art and its practical siblings, design, form the hub from which we think creative thinking radiates out to all the other areas: science, technology, engineering, and math, and how current education is emphasizing those areas. However, creative thinking fuels this innovation, and our intention in our program is to stimulate creative thinking, as well as help students develop processes and technical skills to bring their ideas to fruition. So we believe the practice of art and design and making objects develops that creativity, which is essential to innovation. In other words, art brings STEAM to STEM. So in 2012, we acquired our first 3D printer, purchased with technical fee funds. Also in 2012, Dr. Marcia Welsh became the 13th president of East Stroudsburg University. And shortly after she began, I received a phone call from Mary Frances Poshpak, the Vice President of Economic Development and Research, and she asked me, "Do you know anything about 3D printing?" And I said, "Yes, actually we've just acquired a little one." And she said, well, we were off to the races. Dr. Welsh, in her previous position as Provost and Interim President of Towson University, had been instrumental in funding Towson University's Object Lab, which included several tools for 3D manufacturing, a variety of 3D printers, CNC technology, scanners, etc. And Dr. Welsh now wanted to create a transformative facility at ESU, a kind of fab lab. So the first thing we did was go visit the Object Lab at Towson University, and this was our first 3D printer, bits for bytes. And so with a fortuitous bequest from an ESU alumna, the Hayes Warner Trust, we began work in G3, our former sculpture studio, to develop the lab. The room was painted, new lighting, everything was ripped out, old infrastructure ripped out, and new things put in. Our first printer, large printer beside the Bits for Bytes, was a Stratasys Dimension. Many of you are familiar with that. It's our workhorse still. And the first students to use the facility were the graphic design students. They used them in branding projects, logo designs, and other personal items as part of their personal branding projects. So our grand opening event was held April 16th, but we had been working since the previous fall to develop curriculum that we would integrate into the use of the lab into projects and invite collaborations with the community and other departments in the university. So the lab is invaluable for our concentration in object design, as well as a resource for the university, business incubator, and specific projects and project development. Our multidisciplinary BFA in Integrated Art and Design combines artistry and technical skills to give students a large creative toolbox. We continue to acquire equipment and technology with generous support from grant funding provided by the Hughes Foundation of Monroe County and others. And thanks to the unwavering support of our administration, Dr. Welsh, Dr. Bruno, our provost, and Mary Frances Postupak, and the staff at the Center for Innovation and Research, we are moving ahead. Curriculum-wise, Professor Kolb DeWitt will tell you more about the specifics of that, but we are developing 3 ways to integrate and engage the community with our lab. Through New Mind Design, our student design agency, students will work with clients to provide design services and initial prototype printing. Outreach to the community is ongoing through exhibits and workshops for all ages, and project collaborations are invited where individuals or manufacturers, researchers, or other groups can work with our class or selected students to on specific projects where educational discovery is an integral part of the project. Professional consultations may also be arranged with our faculty on a fee-for-service as available basis. So my colleagues, Professor Kolb DeWitt and Professor Farish Labar, will continue our presentation.
Good afternoon. My name is Jocelyn Kolb DeWitt, and I just completed my first year teaching at ESU. I was a metalsmith, and then I transitioned into a product designer because you can get employed doing that. So a lot of people are sort of questioning, what is product design? And what does a product designer do versus an engineer? If anyone wants to yell anything out, they can do so, or I'll just continue.
Go for it.
So why do you buy the products that you buy? They have to function well, but usually you also want them to look attractive. But the really big thing is there a product that's revolutionary? The iPod, that didn't exist before. So in addition to art and engineering, a really good product designer also needs the psychology. What do people want? What's going to fit into our generation, our society? What do we need? Not, let's make another plastic toy to fill up the world. So a really important thing that we need to teach our students, and that we really strive for this at ESU, is divergent thinking. And I'm so upset with that silly young adult book that took my word away. But really thinking about, what are all the possible answers I could have to this solution? What can I come up with? How can I change this? How can I break away from what's been done over and over again to come up with something new? And at the beginning, it's a pretty off-the-wall concept. All right, just throw ideas out. What'll work? And then we really want them to converge. What makes sense? What's the best application? What's the best way to design this? And how do you get to the point where you know how to ask those questions that's going to get you to that convergent point? So to do this, we use design thinking. And design thinking has always reminded me of the scientific process. You know, you hypothesize, you test, you go back. We do the same thing. What does society need? We're going to empathize. What do millennials want? What product doesn't exist yet? Or what product exists that doesn't function properly, or looks terrible, or both? We define it. We go through that divergent situation where we're throwing all those ideas out. We make a prototype and we realize everything that's wrong with it. And we keep going back and refining those. In product design, it usually takes about 22 iterations of a product before it goes to market. You really want to hone things to the perfect, because once it goes on the market, have you ever bought something that didn't work properly or broke? You didn't want to buy it again, did you? You lost the brand loyalty? So I'd like to take you through some of what our students have been doing. So this is Sam Tabaci, and he's in the back. And Sam is interested in prosthetics. Now, prosthetics is a great application for 3D printing because it's highly bespoke. We can take your hand and make a prosthetic that mimics exactly what you need because we have a 3D printer and we're no longer bound by high-yield injection molds. So Sam made this prosthetic, and when you move your wrist, the hand closes, and when you open your wrist, the hand opens. And he's working on several other iterations right now and other projects, and we're so excited to see what he's doing in the future. So this is some of the tests that our student Evelyn Baronia was working on. Now, Evelyn is a rising junior, but she was interested in laser cutting. And with product design, we really want to find the best application to use, not necessarily just use 3D printing because it's there, but what can we use 3D printing for what it's good for? We also have a laser cutter in our lab. And Evelyn wanted to use the laser cutter. So she took all these materials and she did about 1 million tests. She didn't set the laser on fire. I was pleased. But she got all these samples and she realized that she could selectively remove material until she had a flexible piece of wood. So that's a piece of plywood that she laser cut until it flexed and she gets a living hinge. And she did all these different types of patterns to see what kind of results she could get. And after she was done, I said, okay, now build me a product that uses that effectively. So she made me a purse. So that has a rare earth magnet that shuts, the living hinge opens up, and it snaps back closed. So this is another student, Mike Shoup, who's also in the back row. And I give an assignment that's, you have to make a utensil for a famous thinker or inventor. And Mike said, I'm going to make a cryptex for Alan Turing. And in my head I thought, haha, good luck. But he did it, and it works. The code's Enigma. And it's at our table, and you take that tumbler, you put it into the piece. Every one of those little spirals has the whole alphabet on it. So you spell out Enigma, and it releases and opens, and it was printed in 2 parts. So this is another solution to that same assignment. And this student said, you know what, I love Frida Kahlo. I'm really interested in art. I want to make a paintbrush for Frida Kahlo, but I want to investigate full color 3D printing. So she looked into how to apply JPEG imagery onto 3D models. She sent this out. This is a Z-Core print. And we now have a Frida Kahlo painting on a piece that she modeled specifically for that artist. This student solution was to design a thumb drive for Ada Lovelace. I don't know if you guys know Ada Lovelace, but she was the first computer programmer. She was working with Charles Babbage, and really, Charles Babbage wouldn't have gotten anywhere without Ada. But you can see there's a simulated punch card wrapped around the thumb drive, and this was a bronze print that she sent out. So the students are getting experience with our in-house printers and also with service bureaus, and they can use a wide variety of materials. And they really know their stuff by the time they get through 2 or 3 classes. So this is my last slide. Since it's my first year and I wasn't responsible for these grants, and Darlene and Joni are too nice to brag about themselves, I'm going to do it for them. We have an amazing lab. I think the last count was 7 printers, and we just got a J750 from Stratasys. We have MajorBots, we have Form 1s, we have a Hyrel, which you can pump full of whatever material you want. It is an incredible space, and I feel incredibly lucky to be there. And if you guys want to collaborate, let us know, because we got the stuff. And it's really all because of Joni and Darlene. And I want tenure, can you tell? And this is our J750. It prints in multiple materials, and it also prints in rigid materials and flexible materials. So if you say, I want something that flexes a little bit, we can say, all right, 25% of this, 75% of that, you'll get this flex, and I also want it to be purple leopard print. We can do it. And Darlene Ferris the bar.
All right. I am really proud to be a part of a lab that, as you probably guessed it by now, is woman-run. We also have a great team with Dr. Welsh and Mary Francis as well. All together, we have created this wonderful lab here at ESU. You know, we're also very proud at ESU that we're a very diverse university. And I think that diversity is extremely important right now in the field that we have. 3D printing has opened up the doors for many, many people. It's not just a one-road opportunity for only select types of people, but now it opens up for many type of people. There's user-friendly software and 3D printing that has become quite accessible. And with that in mind, with diversity, with this world that we have now, you can imagine that now we have more experiences that are coming together that are going to create more amazing things, new things that will help make our planet a better place. So, East Stroudsburg University, G3D Superlab is our future to us. As Jocelyn was saying, that we just received the groundbreaking printer from Stratasys called the J750. We have had the opportunity to already run the printer, and we have some samples thanks to Stratasys for providing some for us out on our table that you're welcome to look at. Yes, it is a multi-material printer, and it has a lot of potential, so much potential that I think many people have not discovered yet. And that's what we're looking forward to seeing what our students can kind of achieve and what they can discover as they start to experience this. So, creative people, which we have a lot of in our art and design program. Creative people have the potential to see things differently. They are a really great component to almost any team because they do kind of think a little out of the box. They kind of take things in a different direction. Again, it's that divergent thought process that I think is very important in the day that we live in today. Here is a new musical instrument, music instruments for the future. But if you look at this music instrument, it's not like anything we've seen before. Why does a violin need to look like the violin that we have today? Why can't we try something a little different? And here, you can almost visualize the music. All right, just give some artists a chance, and it would be amazing what they might create. Yes, there's a burger there with a shoe on top of it. You know, just a different way of seeing what you might eat. Another way to kind of explore our senses. Or 3D printed food with a message. Yes, as some of you may know, this is happening right now, and we're going to see more of that as we start to lead into the future. Artists, designers, as artists are the people that ask the questions, the designers usually solve the problems. And here we have fashion. Some amazing works of art, actually, that you can wear, and they're functional. A lot of it also is designed by a lot of things that are in our surroundings. So artists, again, like to observe. They're very attuned to their surroundings, and they soak all this in, and it's pretty interesting to see what the outcome might be. Here's some other examples. These are 3D printed clothing. Only the beginning, that's all I can say. 3D printing clothing, I could see has an interesting opportunity in our future that not only is decorative, but could be functional also. Because of patterns, maybe. Patterns that we may think of as knitting or possibly as like chainmail, right? But what if we could print on a nanoscale? What if the printing has 4D capabilities, which I'll explain a little bit more, which is movable 3D printing? What if possibly this can expand and restrict depending on the weather, whether it's heat, you know, from the sun or rain, that could absorb a little bit of water and then maybe close in. So decorative, yes. Functional, it's pretty exciting. Artists are observers. Something we've seen quite a bit. I hope you've all seen it, because it's quite beautiful, the spider webs. You know, especially in the morning when you wake up and the sun is glistening on the grass, and then you have there some water dew on top of the spider webs and it just sparkles. It's quite beautiful. But what an amazing material. And that's something right now that we're seeing in 3D printing. It is like a 3D printer, that spider, or even a caterpillar, you know, that creates the cocoon. It's creating a fabric. It's creating a structure, something extremely strong and very functional as well, in many ways, as you could see up here on the screen. Here's something recent from Harvard, and they are trying to look at that. They have their eyes open, and they're experimenting with different types of materials, with different patterns, kind of getting their eyes out there and seeing what they can produce in the labs. As we know, the spiderweb is a very strong, very thin web, and I think that we could do some really wild stuff with that idea. Skin grafting, another amazing material. You know, for burned victims, for example, it's just a piece of fabric that's going on top of our fabric that we already have right now composed on our bodies. These are things that I look forward for our students to venture into, because I think that with what they're going to learn in our program, they're going to have that potential and open doors in many of these areas because their skill, their knowledge, their flexible thinking, their creativity, their minds are a little bit layered differently. And I think that everything that they're seeing and they're sucking in as well, they can probably create in a wonderful outcome. Here's a heart, for example. So yes, we've seen some pretty wild things. It's almost like the new Renaissance, you know, where artists can and designers can venture into all these other areas, science, technology, engineering, and math. This was printed from the J750 and the Stratasys. As we've already seen out there in the world, is that something like that can be a wonderful example to maybe save someone's life. This is also graphene, a very light, very strong, transparent, conductive material. I must be on a slide reel here, which is probably good. It's speeding me up. Artists, again, ask questions, maybe saving the planet. Here's an example of a 3D print, you know, that gets us to think a little bit more. It may not be functional the way we might think function should be, but it does open our eyes and it gets us to think. But 3D printing also has saved lives, not just humans, but animals as well. There's tons of prosthetics out there, and no, you cannot create a real animal quite yet from 3D printing, but you can create maybe the tortoiseshell. Some of you may have seen this already out there in social media. It's recent, and they recreated a tortoiseshell, and you know, it's a little bit of faux finishing. Now this turtle has a wonderful new home. All right, so we are rising to higher levels. We're bridging the divide. And yes, there are bridges being created. Something that, again, I see our students venturing into possible worlds of this. Here's an example of an aerial view of a little robotic 3D printer as it glides along the side there, and it is actually building the 3D printer in a very beautiful way. Okay, so our goal is to get our students, to think beyond. We want to have open fields for them, for many people, and maybe for them to kind of have the opportunity that maybe my generations before me never had. Here's Airbus that we saw from our keynote speaker, and here is an example of a new way of designing airplanes, right? Much lighter, much more, would be stronger. And I had another slide, but, and here we have and also an example of new ideas, creative thinking. What if there was a plane in the upper left, but then maybe we had You know, someone attacking that plane, and then suddenly now the plane can separate into 3. All right, so back to the spider. All right, 3D printing on the moon? Yes, it is possible. They are thinking of it because the technology's there. But it was those divergent thinkers originally that thought we can actually soar to the moon. Certainly the convergent thinkers made it happen. Working together was the key there in that regards. So this is a wonderful example of how, as observers, as people that take in their surroundings, how we can create something quite wonderful for our future. 4D printing, here's another example of a wonderful adventure that we will be seeing in our future, where you can 3D print a flat form on the platform, and then with mathematical components, you can actually predict how it's going to bend and move based on certain elements like water or also heat. So it is our goal for our students to think well beyond the standard. We want them to have many possibilities in this world, and yes, 3D printing on the moon is possible. Thank you.